Today we're going to take a look at similar polygons, which we're going to build on our knowledge about ratios and proportions and all that stuff to, instead of talking about congruent shapes, which we've been doing with triangles, we're going to talk about what a similarity is. So we're going to start with some of the basics first. Polygons with the same shape, but different sizes. That is what a similar polygon is. So basically I take a shape and I either kind of blow it up or I shrink it down, and they're the exact same thing, just different sizes. We say that polygons are similar if their corresponding angles are congruent, or not or, and their corresponding sides are proportional. So I need both of those two things to happen. So notice that we're using a lot of stuff that we've already talked about. I have to remember my corresponding angles and corresponding side stuff, and we just talked about proportions and ratios, so that's going to help us here. The ratio of corresponding sides is what we're going to call the scale factor. And the way that you can remember that is basically that's what I'm scaling up or scaling down a shape by. To scale up something means I'm blowing that shape up. If I'm scaling down, I am shrinking it. So like we set up right here or above, if polygons are similar, then their perimeters are also proportional. And that makes sense because if all of my sides are proportional, remember perimeter is all the sides added together, those perimeters are also going to be proportional. So let's take a look at the scale factors. Now remember, here it says order matters because if I'm talking about the scale factor from A, B, C to D, E, F, which are over here, that is going to be different than if I'm talking about the scale factor from D, E, F to A, B, C. So if I'm doing that, if I'm saying something to something else, I start with the first thing. So for example, if I'm finding the scale factor, I'm just looking at what proportion the sides are in. So let me take, for example, 8 from ABC. The corresponding side with that is 12. And I can reduce that down to 2/3. And what that basically tells me is that ABC is 2/3 the size of DEF. So let's look at the opposite way. If I use those exact same sides, if I'm doing DEF to ABC, 12 goes in the top, 8 goes in the bottom. And when I reduce, that's 3/2. Which makes sense, because 3/2 is larger than 1. Because if I had 1 as a proportion, they'd be the exact same thing. But if I have 3/2 as a proportion, that's telling me if I take ABC and I multiply it all by 3/2, my outcome will be those side lengths of DEF. And then again, we set up there the ratio of the perimeter is also going to be proportional. It's going to be, it depends on this order again. The proportion is going to be exactly the same. It's going to be 3/2. So let's keep going. If I'm making a similarity statement, in here it says we've got a symbol for similarity. The symbol, or symbol for similar, it's that little guy, which we've seen in a couple different instances in different areas of math, so don't get too tripped up in that, but that's our symbol for similar. And it says a valid similarity statement must match corresponding angles and sides. So if I'm writing a similarity statement for the triangles above, all I'm doing is I'm going to say ABC is similar to DEF. Now, what I feel like I haven't really taught you guys enough yet is the fact that the order of these should go in the same order of corresponding angles. So for example, if I'm starting with ABC, if I'm going to list angle A first, in my second triangle that I'm naming, I should name the corresponding angle. So I should name D. And then you'll notice that B was second, so I'm going to make its corresponding angle E second. So that's going to help us a little bit more here than it has in the past. So, for example, if they give me something like this, triangle JKL is similar to triangle PMN, that helps me. I can either kind of visualize where I have to turn that and make where the angles are the same, but I think that's a little bit too hard. If I have J first, we already said that similar polygons, their angles are congruent. J is first in the first triangle and P is first in the second one, so I know those two angles are congruent. So for my angles, I'm saying J is congruent to P. And I'm doing the same thing for the other ones. They label K next, so I know, and they label M next in this one, so I know that K is congruent to M. And then finally, I'm left with L is congruent to M. And then that also helps me make my proportion for the sides. The way my proportion for the side is looking is if you see right here, this side is the one that at either end I've got my red angle and my green angle. It's going to correspond to the red and green angle over here. So if I'm making a proportion between these two things, I'm going to say, okay, JK is proportional to PN, or sorry, M. And the way I'm writing these proportional statements is because when I divide, if I were to divide out that proportion, I'm going to get the same answer for every single one of these. So I'm going to say JK to PM is the same as KL to MN. Which is the same as JL to PN. Okay? So let's take a look at this one. Some of them are going to be a little bit trickier because they're going to kind of be on top of each other. But that's okay. And that works because we have angles that are the same. So they kind of just shove this, like right there. Y is equal to Y. They both share that same angle, and that's okay. So I'm going to kind of label this up like I did the other one, just to make it a little bit easier for myself. When I'm naming angles, again, I'm just saying angle Y is congruent to angle Y. They share that angle. And then I know that angle X is congruent to angle R, and angle Z is congruent to angle S. And the only thing that's a little bit different on this one is that parts of these sides are kind of overlapping, but it doesn't really change what I'm doing here. I'm still going to say, okay, here I have side YS. It corresponds to side ZY. Actually, I'll start with Y just to keep it consistent. So I've got YS is proportional to YZ. Equals the proportion between RS and XZ, which is equal to the proportion of, oops, I don't want to do that. I want to start with, I always want to start with the same triangle. So if in the top I'm putting the little triangle in, I need to start with a little triangle on the top in each of them. So I'm going to say RY is proportional to XY. Okay? So let's turn the page, and why don't you try this one? And see what you got. So I'm going to go through a couple of these really quick. How are we actually going to use these? So the way that we're going to use them is to do things like this. If they tell me I have a scale factor of 2 to 3 and I have a side here and a side here, they want me to figure out, okay, what's that other side equal to? The way that I'm going to do that, I'm going to set it up like a proportion. Because right here they gave me a ratio, right? And that doesn't really, we can still do it, but it's not as easy as using a proportion. So if I'm doing 2, 3, again, my numerators always need to be part of the same triangle, because I'm saying this side is to this side as this side is to this side. So I need to figure out, obviously my smaller number is going to be part of my smaller shape. My smaller shape's right here. So I'm going to say, okay, that goes in the top. And its corresponding sign x goes in the bottom. And then I'm just solving this proportion. I'm going to say 2x equals 126, and then I'm going to divide that out and say x equals 63. And then I'm going to do the same thing, exact same process over here. I've got two figures, 6 to 5, so I'm going to do that. Which one is in the top? I need my larger triangle side. You can tell that that one is the one with the x in it. And I'm going to throw 28 in the bottom. And I'm doing the same thing. 5x equals 168. X equals 33.6. Some of these are going to be a little bit of ugly numbers, and that is okay. Don't worry about that. So, okay, I'm going to have you guys pause again. You try those. Number 6 and number 7. Try both of those and see what you get. All right, now the last thing we're going to take a look at in this section is number 8. Again, I think it's kind of helpful when I look at this to mark up my angles to see what I've got. So I know that A is first in this triangle and K is first in this one, so I'm going to say those two are equal. G is second and X is second in that one, so I'm going to say those are equal. And then I got M third and D third. And that's going to help me set this up. So let's see. Let me take a look at what I've got. I've got this side right here. So I'm just going to go ahead and put that, start my proportion right there. And let's see, what do I have that corresponds to that? It'd be this one. It's the one with the blue and the red angles on the end. That's my proportion for that. Equals, now I have to go back to my original triangle that I started with, because remember, all your numerators should come from the same triangle, and all your denominators should come from the same triangle. So like right here, I'm going to say, okay, that's 32, corresponds to x plus 3. And I think that's probably the trickiest part of these, actually setting up my proportions. Because now, I'm just going to solve this like I solved proportions in the previous lesson. I'm going to cross multiply. And solve that out. And when I do all that math, I'll come out with that. X equals 21. And if I go back and plug all that in, I would find, hopefully, I should. If I were to plug that in here and here, I would find that these proportions are equal to each other. Or if I plugged it in here too. That's really where I could start, because that's what I'd be setting it up in eventually anyway. So why don't you guys try this one? And then that'll be it for today. We'll try that one, and then we will pick up on this tomorrow.